ready to go over the answers. Okay. Put the extras somewhere. Okay, so the first one.
What is it?
Yes. Second one. Yep. Third one. Fourth one. And last one. Right. Wow. That was easy, huh? And do we know what this does?
Oh, I didn't read it.
Yep.
Counts the number of clicks.
So yeah. So it should be, as you click on it, the number will increment. So there is a mistake on here that makes some of this code not really matter at all. Can anybody catch which? It's in one of the three code segments. No. So I mean, it starts off as 0. No.
The dot is missing in CSS, the click count.
So you're close. Since click counter is not an element that I've put anywhere on here, right? So click count was the name of a variable in JavaScript, but the element itself was called num clicks. So if I wanted to style the actual element, I should have done hashtag num clicks instead. But I had already put it in the copy machine at that point. So you guys can just pass them all in this direction.
I only have that. Mark that. So like, you know the MP files?
All right, so that looks good. So, quick notes before we get started on today's topic. Your exam 2 is due tonight. So, there it is. If you haven't done it, please go on Canvas, fill it out, submit it back on Canvas. I accidentally did not click publish on the grad student section, which only affects 2 of you. So I have clicked it now, and you can submit it if you'd like. One of you emailed me, so that's fine too. So bad HCI there maybe, but okay. Other things happening. Homework 3, which is just going to be you telling me kind of what you'd like to do with a couple of the lectures that we have open right now. I will post that later today, hopefully right after class, and then that'll be due in a week. Your quiz 3 and 4, I have not posted grades for yet, but I will do that by Friday, I promise. I did go through, I think, everybody's homework 2. So you all should have gotten grades and feedback on that, so the input-output devices, and I quite enjoyed a lot of your submissions, and they fit nicely with today's topic. So I'll share with you kind of what the most popular ones were and what kind of the most outrageous ones were. In other news, we have Project Checkpoint 2, which will be next week. So that will be us talking to FedEx remotely and each group presenting. I've put up on Canvas both the requirements for the checkpoint, which is just a group assignment, so 1 submission per group on Canvas, and then your the order that we'll present in. The order is flexible, so I've put 4 presentations on the first day because I'm optimistic, but it could very well be that we only have 3 here and we have 4 here or something like that. So we'll just see how it goes. Just real briefly to talk about checkpoint 2. I mentioned in the last class, the main thing is going to be that you're going to want a comprehensive functional prototype that incorporates kind of the feedback that you were given at the last presentation. So in terms of actually what you need to turn in, the presentation itself, you can submit that on Canvas Tuesday by 11 a.m. just so I have it ahead of time. If you have things that you want to demo that are online somewhere or something, I'm just going to have you run it on my laptop, so it'll be able to access that provided that the MSU network is up and everything. And if you have software you need to have installed or run, or you need me to have Windows or Linux or something crazy, let me know a little bit ahead of time and I'll get that set up for you. Let's see. In terms of grading for this portion, I think this is 15% of your overall project grade. It's checkpoint 2. So please put your group members, your name, project on there. The main thing is the full design prototype. So it doesn't have to be full high fidelity for every feature, obviously, but you kind of need to show FedEx that you've considered all of the requirements, you have an approach for all of the requirements, very least you have a placeholder, and then it's best if you have as much interactive functionality as you can. Now, I would encourage you to do a live demo if you can. So if you're using a prototyping tool that lets you do that, or if you're writing an actual app and you can just pull it up and run it and do that, that's great. If you're not quite there yet, if it's kind of like you've got, it's kind of hacked together, but you can do something like make a video of it. So if you can screen capture things, splice it together how it should work to show the interaction flow, that's perfectly acceptable. Also, if you're going to do the live demo, please do it ahead of time as well and screen capture it. That way, if you do have a problem during your demo, if something doesn't connect, if something is broken, we don't have to spend 10 to 20 minutes trying to fix that. We can just go to the video. So this is just good life advice in general for whenever you're demoing any kind of tech product. Always have a nice backup video that you can fall back to. And you don't even have to tell people that you're falling back to it. Once you fail enough, you get really good at just kind of pretending that you intended to go to the video. So, but please demo something. In terms of incorporating previous feedback from FedEx, just be sure to highlight the feedback that they gave you. Talk about what you did with that feedback. It's fine if that feedback wasn't useful, if you didn't go in that direction. Just acknowledge the feedback, and that way they know what they said last time, which makes them less likely to say something contradictory or to think that you haven't done anything. So include that. And then also, if you can include, and this can just be a slide or two, but basically a high-level plan that says, what your course of action will be to make the final product. So it might be that you've got your prototyping all done in Figma right now, and your plan is that you're going to export some of that, implement some web stuff, or maybe you're going to make an iOS app or something like that, and then you're going to test that and present that at the final project. But you should include just a little bit about the technology you're going to use, and then also a little bit about your schedule, how you plan to accomplish that as a team. And that's mostly because you've only got a few weeks really to get it going. And so you don't have to be super detailed. You can just say, like, first week we're going to set up our basic framework and code repository and get the basic screens laid out. And then week 3 we're going to do testing, and week 4, It doesn't have to be very detailed, but just let me know kind of what your plan is and what your intentions are in terms of getting it to the final project. In terms of time, we've got about 18 minutes per group, okay? And so I would suggest, based on last time, the amount of questions that FedEx asked, which it's no guarantee that it will be the same, that you kind of give them around 8-ish minutes. Expect about that amount of time for them to talk back and forth with you. So I try to shoot for 10 minutes or less on your presentation. Certainly, again, I have no time requirement for you. If you can do it all in 3 minutes, do it all in 3 minutes. Also, everybody in the group should be here and should come up to present, but you don't all have to have a speaking role if you don't want to. You can certainly have someone go through most of it. You can do handing it off. I think everybody pretty much equally divided it last time, worked really well. Whatever you want to do, it's not going to make your group's grade or your individual grade any different based on the way you structure your presentation. So, do we have any questions about any of that, checkpoint 2 or anything else? Okay, good deal. Okay, so last time we talked about UI technologies part 2, and we flew through all of this. I've posted the code for this on Canvas. It's just in a zip file in the lectures folder with yesterday's date on it. So feel free to look at that and play around with it a little bit. But moving on. Today, we're going to look at non-traditional interfaces. So traditional interfaces being a screen and a keyboard, mouse kind of thing. Kind of want to give you a feel for HCI that's not just web apps, it's not just mobile apps, although that's the most common thing we do kind of right now. So there's a lot of areas to cover here. Definitely, if I'm talking about an area and you know of something interesting or cool or have a question, feel free to interject at any time. You all supplied some very nice examples on your last homework, and some of them are pretty new to me. And so what I've done is I've kind of split this up into different areas, and I've arranged it roughly in order of when these things have become available in a widespread way, or I don't want to say they've been adopted widespread, but just that there's a general awareness that they exist. So, I know I said non-traditional, but I've got to throw this in there just so we can kind of get the timeline going. So we started off command-based kind of interfaces, right? Just text and text in, text out interfaces. Still really common. Still used in quite a few applications. So, like when we were doing the web stuff the other day, we saw you had like an interactive JavaScript console. That's still a command-based interface. If you're using like an IDE, like even in Visual Studio Code that we've been using, or like Sublime Text, you can do a quick keyboard shortcut and you'll get kind of this search box that pops up, and you can type in something and quickly find a command that you want. It's similar on like on a Mac. If you do usually Command Spacebar, you get a spotlight window and you can just search everything and find the document you want or the application. That's all command-based still. And so while command-based is kind of the first form of interface that we've had, it's certainly not gone. It's certainly not dead. And it's really useful in a lot of circumstances. For us, for people that program and computer scientists, it's still usually a big part of our day-to-day development efforts, and it can be really useful for that. But for the most part, today we use kind of the GUI plus WIMP approach to things here, which is Windows icons. Is it mouse? No, it's pointer. I don't know what the M stands for. Anybody remember? All right.
Menu.
Menus, yes, good, okay. If we had extra credit, you would get it. But yes, okay. So Windows icons, menus, and pointer. And so this is literally my laptop. This is what the modern kind of desktop is looking like today. Still Windows, still all these menus, pointers, and tons of icons. Icons are a huge thing across all of the platforms that we use. So we've talked a lot about this already this semester, so I won't go into any more detail on that. But kind of the next phase of interface beyond just this is what's usually considered multimedia interfaces. So if you think about it, when we first started to do kind of the Windows and the GUI thing, the content of the Windows is pretty static. There's not a lot of interactive stuff happening. Nothing like playing videos, hearing sound, and manipulating things. So when we talk about multimedia, this is kind of an example of that. So this is just an application that comes on Mac OS by default. It's a graphing application, right? And so this is kind of an example of a multimedia interface. And so in this case, you can add equations here, you can manipulate things, and you can see this visual happening in real time. So this is a pretty common paradigm to see. And actually, this is a great application that's just built into to the OS here. And I remember it being really useful just for math classes. But it has 2D environments, 3D environments, and a lot of great equation editing going on. Although it doesn't seem to do too well with the dark mode theme. There's like this bug where this text isn't white for some reason, but that's kind of beside the point. So this is just an example of kind of the multimedia interfaces that we've created. And you can certainly, this doesn't have to be just on the desktop, but the idea being that you're dynamically manipulating the interface. And so that brings us, this is kind of a side note here in terms of interfaces. There's a whole field of just data visualization, and that's become a bigger and bigger thing. But within the study of interfaces, these are usually called dashboards, right? And the idea being that a dashboard is a display that's not really meant to be interacted with in a lot of cases. There are certainly displays that allow some filtering or some interaction. But if you think about if you're at an airport or anywhere where there's like signage telling you what's going on somewhere. So even in some of the newer buildings on campus, outside of each room, there's a little kind of screen saying oh, this is what's scheduled in this room today. When we think about dashboards, we think more about kind of the thing that's letting you see what's going on overall in a system. So this is an example of an app that is for a corporate environment where you've got different meeting rooms, and you need to schedule those rooms among different employees and different teams to meet in. And so it's giving you a visual of who is where in your whole building. This is kind of another dashboard example, and we'll talk more about this as another type of interface too. This is becoming more and more common. It's kind of a personal dashboard. So this is from I think this is AutoSleep is the name of the app. So it's just an app that uses the data from my watch and my phone and tries to figure out when I'm sleeping and if I'm sleeping well and what's going on. But it's providing all of this data. Hey, look, there's spring break, right? So it's giving me this data. Hopefully, it will have some meaning to me. And indeed it does. So you can look through it and you can find certain trends. You can find out when we were running behind on building a robot, or when a conference deadline was coming up, or anything like that. And you can see, when we have to crash completely and get 12 hours of sleep because we only had 2 over here. But so this is the kind of dashboard that's starting to show up more for individual use. We see this too with features like screen time on iOS, on Apple's platform. I don't remember what the Android equivalent is called. Does anybody know what it is? Basically, it's a feature in the mobile OS that tracks how much you're using the device. So, when are you picking it up? How long are you engaged with it for? Which apps are you using? Which notifications are prompting you to pick it up? And this is part of a movement that I guess a lot of tech companies have felt the need to take on, and it seems focused mostly on children and trying to moderate their usage of devices. And that's a whole discussion about, what's the right thing to do there. But it will present a dashboard that's similar to this. And so I know every, I think Sunday or something, my watch will buzz and it says your screen time was either up or down so many %, right? And then you can go in and look at it more. If you enable your family sharing for this, you can see your entire family's screen time. So the idea being that you'd have a dashboard of what your children or family members, how their screen time is working out for them. And so this is an interface that the interface itself may not get a lot of interactive use. So certainly you can see on here there's some filtering options, drag on there. But in general, to take action on this data is not going to involve the interface. It may involve telling your advisor that you have to sleep or you're going to die. Or it may involve asking your kids to not use the iPad so much, or whatever it might be. But that's the idea of dashboard interfaces. So it's all about data visualization. Maybe we'll get a chance to talk about this in a future lecture, but data visualization being an entire field on its own, the best resource, there's a guy named Edward Tufte, and he's written a number of books about visualizing data, and they're quite wonderful books. And there are a lot of little nuances to visualizing data well. And so I'll try to get some links to those resources for you. But I really recommend looking at them if you're ever doing something where you need to present, data over time or anything that's got a lot of options and a lot of different ways to view that. You want to think about that.
Can you repeat his name one more time?
Edward Tufte. I think that's Tufte. And I want to say, actually, let me just look real quick. So, I'll just drag this over so you can see it real quick. So here are some of his books here. So I think one of his first books was a visual display of quantitative information, and that's kind of the classic one. But he's written a few others, and they're all really good. So. Okay, so after dashboards, this is kind of an interesting area of interface, and this is just collaborative interfaces. So I've got two examples here. One is more of a hardware-ish example. So this is Microsoft's, I guess it's a hub now or something. It used to be called the Surface, but then that became something else. It's basically a giant multi-touch monitor, and it's useful. They've made several models since this version. They do all kinds of nice things like video chat and collaboration. But the idea being multiple people can work on this interface at the same time, and it's really these are very similar to a blackboard or a whiteboard. And so we also see this kind of idea happening with things like this is just Google Docs or any kind of collaborative software where you have people working on the same product at simultaneously, and so providing visibility so that they can see what each other are doing and collaborate. This is kind of an area of study that's also a subfield, and it's just looking at how do you accommodate multiple users trying to accomplish a task. And so collaborative interfaces have to cope with a lot of things. In applications like this, where you've got multiple people working on the same display, you have a lot of lower level hardware, algorithmic issues in terms of, I'm going to have a lot of people touching this, and how should I interpret that? How should that modify something? How do I ignore accidental things? When you're doing something like people from multiple locations working on the same document, you've got to worry more about resolving conflicts. And how do I communicate to a user that, my state is out of sync and I'm not sure which one to go with? Or how do I communicate that I'm erasing everything that they just wrote because this other thing is more recent? And as when you're programming that, how do you ensure that you're not doing something that's not intuitive to what the user actually wants, even though timestamps are telling you this or that, that may not necessarily be the way that it turns out. Have any of you guys worked on building any kind of, software that involves real-time collaboration, anything like that? So I encourage you, if you get a chance in some of your classes, you probably will, and whether it's in a software engineering or a senior project, to look at doing something that involves having multiple people connected to software at the same time, because you can learn so much trying to deal with that kind of situation, because suddenly you're going from a scenario of having a single input-output stream to having however many people are connected. And the nice thing is now, from a tech perspective, it's easier and easier to implement something like this. Like, you can throw together a collaborative web app in 30 minutes. There are great demos on how to do that, and that's really come a long way probably in the past 10 years. So that's something that's really interesting interface-wise, and certainly has applications outside of just business and documents. You'll also see this with more creative things or more recreational things like gaming and stuff like that. So I've got a video. Actually, I think I've got two videos related to collaboration. Let's see if I have audio.
Reflect is an innovative, easy-to-use and fun tool for efficient collaborative training and meetings. It detects the sound positions and shows who's talking through lightened LEDs on the tabletop, and at the same time visualizing conversation dynamics. Reflect shows each speaker's current participation level and the distribution for the entire conversation.
Let them see the light, music and to
The speech path tracks the way of the conversation and its intensity between people by leaving a trace. Reflect also features interactive voice-controlled games.
and
The speech analysis shows the different moods of the participants. Using Reflect, you can detect dominant and passive group members and make people aware of their own and others' communicational behavior. Reflect is also an ideal tool to be used to enrich interview activities, negotiation training, and conflict management. Reflect has been developed with the latest research and technology by the Swiss Institute of Technology in Lausanne, Switzerland. For more information on purchase options, please visit our website.
Okay, so it's a little bit, it's an older research project, probably at least 10 years old at this point. But it's kind of, I didn't really know where to put it in the scheme of interfaces, because it's got a lot going on, right? In some sense, it's a dashboard showing, who's participating in the conversation, more or less, which that alone is quite intriguing. And what I would like to do, I don't think they ever did this when they ran studies of it, but it's supposed to show you like who's, if you're speaking more, you're getting more lights or whatever, and this person's not. I would like to actually make it, do the opposite, but not tell the participants, to see how that would affect them, so they would think that they're speaking, too much when they're actually not speaking at all. But I don't think they ever ran that study. But anyways, the idea here is that we're starting to branch out beyond the screen quite a bit. And we're also branching out into having these things that are physically embodied in the world, and they're not just general purpose computers sitting off to the side. So in this case, this is a table you can sit at. You can do everything that you could do with a regular table, but you've got this added visualization that's happening in front of you. And in this case, because it's meant for a group, it is a collaborative interaction as well. So that's kind of interesting. Now I've got another video, and this is just to show you, this is one of the earliest video kind of telepresence applications that was created. So we're going to watch just a little bit of it.
This is one of the 3 working prototypes that we built. It consists of a color LCD monitor, a camera, and a loudspeaker, and comes in a very compact package. It tilts forwards and backwards and has a telescopic feature which enables you to adjust the viewing position and the camera angle. Let's see it in action. What we have are all 3 prototypes on my desk now, and I'm having a round-the-table conversation with 3 colleagues. On my left is Tracy. Hi, Tracy.
Hi, Bill.
And in the center is Abby. She's sitting right across the table from me.
Hi, Bill.
And over to the right is my daughter, Katie, who's joined us to see what we're doing. Hi, Kate.
Hi.
Now, to preserve the notion of around the table, Katie sees Tracy across from her, and Abby sees me across from her. Now, Abby, where's Tracy?
Tracy's over there.
Okay, and Katie?
Katie's over there.
Okay, and where's Abby for you?
She's over here.
Great. Now you'll notice that the space occupied by each remote participant is very small, and yet they have their distinct location, which means that the sound comes from their own personal space. But furthermore, each person can see where each other person is directing their attention or their gaze. Eye contact can be maintained because of the small angle between the camera and the monitor. And there's enough space on the desk for me to do other work. Therefore, through the use of industrial design, we're able to get an implementation of the concept which is actually testable and usable in a real-world context.
So far we've been testing the prototypes. The next step is to do some behavioral studies to reveal the differences between this design and current practice.
Okay, so a lot of things that kind of jump out there. So obviously, we're all accustomed to a world of using something, Skype or Google Hangouts or whatever, FaceTime, where we have one screen, and sure, you can have multiple people on that screen, and maybe it kind of does a little perspective effect or something, so that you can talk to them. But kind of the premise here is that there is some importance to this physical and spatial layout in the environment. And so, this is from maybe 20 to 30 years ago. But if you look now, how many people have seen like a Cisco telepresence system for business meetings? It's a table, and then across from you, it's just full screens, and it's a table somewhere else. And so you can literally sit across from people who are at a distance, and it feels, like everything's at the right scale and distance, and the audio's there. And the idea is to try to put you in the same physical space. And so this becomes kind of an important aspect of collaboration. And we certainly see this in robotics. I'm trying very hard today to not drift into robotics. I will spend a lecture on robotics, and I will bring lots of robots that are fun and stuff down here, but I'm trying hard not to go too far into what we consider robotics. These little machines are not moving around on their own, so we'll just kind of say that makes them not robots, although that's certainly arguable. So moving on from this collaboration thing that we've got going on, which has been going on for a while, the interface that really changed things most recently, I guess, for us, has been the idea of having mobile and simple touch interfaces available to us. And so specifically having devices where we can do things, where we have multi-touch. So I don't know if any of you have ever used touch devices that are resistive and not capacitive. So capacitive devices are, what's in every mobile device now. It requires you to use a capacitive object, which your skin is, to actually interact with it. And you can put multiple touch points on it with no problem and track that. So resistive touch, older touch screens, you see them kind of, like if you ever sign a credit card thing, that's usually resistive touch. Well, there's some other technology there too. It requires pressure on a physical grid that's embedded in the screen to actually get the touch. So multi-touch is not easy to do with resistive technology, but it does work even without capacitive objects. So you've probably experienced, your touchscreen not working whenever you have gloves on, or when the temperature changes rapidly, or humidity goes up, and it needs to recalibrate. We've gotten really good at dealing with that, but that certainly is an issue. So, and when I say simple touch, I'm including multi-touch in that, the ability to pinch and scale and to, put a full piano on your iPad and play it. That's part of this, and certainly that wasn't something we had immediately, but it's something that's widespread and just about everywhere now. But we'll talk more about kind of what else we can do with beyond just that aspect. So the other thing that comes along with touch is the idea of the stylus or the pen or the Apple Pencil, and so I think we've all probably interacted with these devices, and some of you included them as in your homework as input-output device kind of things. So I mean, I have these things just because we have them laying around, but we've all seen them. So here's Apple Pencil, for example. What's really nice, I guess, about Apple's implementation is that they focus a lot of effort on low latency. So actually, as you make a stroke, it's very, very fast. And this is the first generation one, I think, and it's still very impressive. But since then, and I think just recently, they had an update to the Pencil. It's only gotten better. But when we have something like a stylus, what you can actually do, and there are a lot of different underlying technologies for the stylus, is you get things like you can get pressure of it. So I think like Apple's is maybe 1,024 levels of pressure. If you look at some companies like Wacom tablets that are used for a lot of artist applications, you'll see that they have varying levels of pressure. And you also get some nice information, for example, the tilt of this device as you're drawing, which is really useful if you're drawing or sketching and you want to mimic that physical behavior. The other thing that you can get, which the Apple Pencil does not give you, and annoys me to this day, it took us like 10 years to get a pencil because all we needed was our finger, but that's an aside. If you take the pencil and you turn it over, it's not an eraser. Okay, and if, like, I spent years using Windows tablets, just straight up full Windows OS tablets, and a lot of them used Wacom digitizers. And in that model of things, if you turn your stylus over, the eraser just erases. And this is a huge convenience when you're taking notes, because otherwise you've got to go hit a modifier key or something to make this into an eraser. So we've got that kind of thing going on. Let me see if so like here is, this is one that I just grabbed out of the lab. This is just a Surface Book, which is kind of interesting in itself. I don't know if it'll let me take it apart or not. So these two pieces separate here, so that this can just become a tablet. And they actually used a memory muscle wire approach to doing that. And so sometimes it fails in software and you can't actually attach it, which is crazy, because this bottom half actually contains like the better GPU and some additional battery. So, but if you look at the pen that's used for this, and I should say, like, this is a good example of kind of how far we've come in terms of This can be the laptop. It can be just the tablet that you want to write on. It includes all of those things. It can do the capacitive touch. And if you look at this pencil, you've got your regular point, and you've also got the eraser end here, which is also a button that you can click. And then you also see there's some modifier buttons, which I think the second version of the Apple Pencil allows you to do some gestures or something. So we see things like that happening, and I don't know, how many people have used a stylus, or currently use a stylus for any like extended period of time? Okay, so this half of the class is the stylus. So like personally, I really enjoy like when I'm in class taking notes just by handbook and with digital ink. You probably notice anything that I grade for you is done with a stylus, usually an iPad or something. So this is a convenient interaction scheme because it provides that freedom that we have to draw and to just kind of free-form interact with things. Also, what's really nice, we talked about capacitive and resistive. So if you have like this is capacitive. You can use this, which is not capacitive, or if it is, at least the device knows where it's at. And so there's a separation between these two inputs. So now you can do things like drag to modify something that's happening here. And that can become very convenient in certain applications. And so that's also a big area of study is what's called, for a long time, palm rejection. So when you have your hand just sitting on here and you're writing, you don't want this detected as a touch, or things will go a little bit crazy. So it took a while to get that right. But for the most part, it's pretty good now. So before I move on from the stylus and the hardware things, a lot of you mentioned, let's see if some input devices, so like game controllers. So this is one that has lots of mappable buttons and things. There are a ton of game controllers you can find out there. Some of you submitted some very interesting ones. Also submitted was, so this is pretty cool. We've been using this a lot in our lab. It looks like a remote. But it's actually, so it's got a keyboard on the back, and we have versions that have like a trackpad on them too. This one actually has a IMU in it, so kind of like a Wiimote or your phone or something. You can use it kind of like just pointing at the TV or the display or whatever. This turns out to be really convenient, especially for robotics, where we do a lot of work where we have small computers on robots that don't have displays or keyboards or mice. And when things go wrong and you really need a keyboard or a mouse quickly, you can use something like this to do that. Let's see. Okay. These are kind of, this is interesting. So this is something that I got recently for Christmas, and I've not had a chance to use it yet. But so there's a ton of devices like this. So just custom control structures, right? Control services, I should say. So this one is, generic in the sense of you can map all of this to whatever it is you're doing. You'll find a lot of people using this for artistic things, for design tasks. So like, for example, you could map these sliders to different, adjustments in Photoshop or something, right? And so if you want to tweak highlights and shadows, maybe this is a highlight slider, this is your shadows or something. And you can do this, and you have this physical representation that's in the world. And, it only gets crazier from something small like this. But this is just an input device. And so it's really easy to program and use it for whatever you want. But we see this too if you ever look at, like if you go to a concert or something and you look at where they're running lighting and effects and sound, you're going to see control surfaces, huge control surfaces like that. Yes? I don't know. My now fiance got me this for Christmas, so I think it's like $100 or so. I've really been wanting to use it, and we're already to like almost to April, and I haven't used it yet. So, but I'm getting closer because I've got it out again. But yeah, it's really cool, and there's just a ton of software available and extensions and things to plug it into different tools. So you'll see custom control surfaces like that. Let's see. Wait on that. Okay, so let me jump forward a little bit. So moving on, speech has been around for a long time as a way of interacting with systems, but it's only recently that it's become pretty good and popular. So we have Alexa, Cortana, Siri, Bixby, whoever. They're all hanging out on all of our devices now, listening and ready to help us. And there are two big components to speech. Has anybody written any software that deals with speech, just whether it be an Alexa skill or anything? Okay, so no. So, I mean, you might want to try it out if you have one of these devices. But there are two big components to speech. One is taking the audio that you hear and converting that to words accurately, and the other is understanding what those words actually mean. Those are both two horribly difficult things to do. We've gotten pretty good at the first one, at least for native English-speaking adults. We've gotten pretty good at it. And I should say we also, when we look at speech interfaces, so like in this case, this Echo Dot or Spot or whatever it is, it has no visual feedback apart from this LED ring. Okay, you'll see like more of the current devices may incorporate a screen as well, but with this, it's also localizing where the speech is coming from in the room, which is pretty important. Because this is meant to be a fixture in an environment where people live usually. And so it needs some awareness of its embodiment and context in the world. And so that's always a concern with speech interfaces. The other interesting part about speech is that you do have to design carefully. If you ask a lot of the assistants to set a timer for so many minutes or an alarm for a certain time, when they repeat it back to you, they'll usually repeat it back in a different way. And that's on purpose, to help you verify that it really understood the right time, because kind of the stakes are high for it to make a mistake on something like an alarm or a timer or a reminder. And so we see things like that. We also see that there are certain interactions that just don't work well through pure speech interfaces. So that's kind of come to a point where we do see like the home assistants, like Google's Assistant, Amazon's Assistant, are starting to incorporate screens on a lot of their devices now. And it's convenient because sometimes it is easier to show an image or put some text on the screen rather than trying to convey information verbally between the device and the user. And of course, all of these assistants that are living on mobile devices already have that available to them. So let's move on to gestures. Okay. So when we talk about gestures, there are kind of two major, I guess, categories of gestures. One being touch gestures, so in contact with a surface, making some kind of gesture, so like pinch to zoom is probably one of the most universal ones. But this also extends to like the trackpad, on your computer. So like a 3-finger swipe will put me into my other desktop, or pushing up will show all of my windows. Gestures are a nice way to kind of build shortcuts and muscle memory for users. A lot of us have adapted to those gestures on our mobile devices quite well. So swiping from the bottom up does one thing, or the top might do something. It's very annoying that Apple has decided that some devices should do one thing from the top while others should do it from the bottom. I don't know what that's about, but they should fix it because it's confusing for me. So like my phone is a phone that still has a button on it, which we'll talk about that too, that I love. And so when I need my control center or whatever, I swipe up from the bottom here. But a lot of people around me use a phone that has Face ID and no button, and when they want their control center, they swipe from the top. So it's a little bit interesting. And then when you get it on the iPad, it varies. All using the same operating system, I should say. So we get things like that. So gestures are very powerful, but there's definitely a process to getting a user to understand and use your gestures. If you look at a lot of the mobile operating systems, I've followed Apple, like iOS development for a while. There are a lot of gestures that were picked up, in iOS 3 or 4 and then dropped because it didn't work well enough for a majority of users. And so these things do eventually get ingrained kind of in culture where, if from the time you were a child you've been able to pinch to zoom or swipe between apps, you don't really think about that as being something special. So that's gestures that are actually touching a physical surface. We also have things like gestures, and in this case this is showing what I think is a bad idea, but this is in an operating room, and they're using gestures to like zoom and pan on their imaging displays over there of the patient. I'd like to see like the Siri version, so we see this kind of thing. This is a non-contact gesture, and so in these situations you're using something, some kind of imaging technology usually, so a visual camera or a depth camera, or just IR or LiDAR, radio waves, whatever you want to use to track the user's hands in this case, and to see what they're doing with their hands and then interpret that as a gesture. And there's a lot that goes into that, and there's a lot of difficult work, and thankfully a lot of it has been done about ignoring unintentional things. So I worked on a project when I was an undergrad, and I was using software that just used a webcam on any computer, and it would track, like 40 points on your face, right? And also give you the rotation of the head in space. And so we were using it as for someone who's controlling a robot remotely. And the robot had a screen with a camera on it, and the idea was that when you would look, it would move. And so you were using your own body to control it. Well, what's interesting is, you can be doing that, and then someone could say, hey, what's, this or whatever, and you look over to answer them. Well, you need to be able to distinguish in your software that I'm glancing off to do something, and the robot shouldn't swing its head with me when that happens. So we see a lot of work in doing things like that. Today we have things. So a lot of you submitted the Microsoft Kinect, at least some version of it, as one of your input-output devices. And what it does is it's full body tracking, and as the versions of the Kinect went on, it's got better and better. And Microsoft really solved a hard problem for us with that, and they did it in an impressive way. So if you're interested in that kind of thing, you should look up the story of the Kinect and how that was achieved, because it was basically a brute force effort, and it worked. Yeah.
Do you know if they use the newer Connect technology that they built for the one that never really took off with consumer? Is that still pushed in like academics and business use?
Yeah. So about a year ago or so, they told us they're not going to make it anymore for researchers or for anyone, and that's we all went out and bought as many Kinects as we could. Because it's pretty essential for us. So in robotics research, we use Kinects quite a bit because we need to know where people are, what they're doing. So yeah, Microsoft, as far as I know, they are not making the Kinect standalone anymore. Now the technology in the Kinect, so what's interesting is Microsoft acquired a company, I believe they were called PrimeSense, for the first Kinect that they made. That all of that intellectual property was later acquired by Apple and now is the thing that runs Face ID. So it went from being the size of a Kinect like that to now being the size that it is in an iPhone. And so we see more and more of that. Intel is another big player with their RealSense devices, and they've worked to integrate those in directly to tablets and laptops now to get 3D sensing for users. And you can do a lot with this. The big thing is to look at a person's facial expressions. Maybe you can detect how they're feeling like that. You can certainly detect what they're looking at usually. So like I brought this one. This is one of these smaller RealSense units. This is a development version. This will actually go inside, like, something the height of this bezel. They'll put this inside of. It's not nearly as large, but this will give you, pretty high fidelity data about tracking points in the face, body orientation, posture. There are different versions. This one is a long-range version. It would have no problem tracking you, from over there to over there, and tracking multiple people at a time. So Microsoft also, like their latest Kinects, could do a really good job tracking, 4 or 6 people at a time if you needed to. So Intel's made a lot of these since then. A lot of the hard work is done in hardware. And that's nice, and it makes the output very usable. Another one that kind of goes along with this, that a lot of people submitted eye trackers as their input-output devices. So this is one that was made by a company called the Eye Tribe. They were in the Netherlands. So it just sits, yeah, here you go. So it comes with a little tripod. So you can clip it on something, but the idea is that if you had like a computer monitor, you can literally just sit this down below it and kind of point it up at the user. And it'll allow you to see with pretty good accuracy where someone is looking on a screen. This is really useful in situations where people don't have the ability to actually use a mouse or to touch a screen or give input. The only problem is, I guess, how many people have used an eye tracker? Anyway, use one? Do you know which one it was? Or? Okay. Okay. Yeah. So yeah, we definitely see them a lot in studies. You'll see them used in marketing as well. So like, where are people looking on my ad or whatever. But if you've ever used it to try to control a cursor or to, choose things on a screen, it works, but it's very tiring. You get worn out pretty quickly. So that's something to think about. Now, where this is really interesting, and we were using it recently, is just to get an idea of where a user is looking on the screen and where they might be going next in terms of predicting which part of the interface is about to get used or need to be active. And so if you are doing something that's going to require some computation to occur for a certain section of an interface to be used, if you know that's about to happen, you can start that early. And that can be incredibly helpful. Okay, so I've got a video here, and this is a Disney research video about gestures and controlling a robot swarm. So Disney Research does a lot of really cool stuff. So basically these robots are just little LEDs that are able to move around, and they're using a motion tracking system to track the hands. they will continue. Definitely check out Disney Research if you haven't. A lot of cool stuff that Disney does. Since we're getting to where we have about 10 minutes left, I'm going to jump up to haptics because this is a big area. Maybe we'll talk about this more in detail. So we see it definitely in our mobile devices and the things that we wear. So haptics, basically giving you a sense of touch feedback. In a lot of cases, it's vibration. A lot of you guys submitted, I guess quite a few of you submitted the various Nintendo devices, but the Switch, if you haven't used it, the little Joy-Cons on the side here, the haptics are very impressive in here. So the actuators inside can allow you to simulate, kind of the feel of maybe like holding a cup of water or something. Different things that are really interesting in gameplay for sure, but just incredibly convincing and useful and giving you kind of that real world feedback. Another thing that we see in haptics, so like the trackpad on Apple laptops now does not physically actually move when you click it. That's all simulated haptics, and it is really difficult to tell that is the case. I don't know, do you?
Mine stopped working once.
Yeah.
And like the haptic stopped working once.
Yeah.
It's awful.
It is, yeah. Like I've had a couple of times where I have like a crash or a kernel panic, and the firmware for the touchpad stops, and it's like all of a sudden you can't click, and it's a new level of panic. So yes, that's unfortunate. But it's very impressive what can be done in software to tune this to different things. Another interesting area of research, and maybe we'll talk about it later. By oscillating at different frequencies across a material like this, you can create different texture surfaces. Disney Research has done a lot of this. So imagine being able to change this to a rough surface or a very smooth surface dynamically. So that's really, really interesting stuff. Before I get to VR, I will briefly tell you about another touch interface. This is actually, I pulled this off of our therapeutic robot. So you see this fabric here. This is capacitive fabric. It is the same technology that's in these screens. We put this under an exterior covering that looks like a stuffed animal. And with this, we can actually tell how far away capacitive objects are. Because we have multiple, we can detect gestures like petting or patting, or pulling, and respond to that. So that's another big area of touch interaction. Virtual reality, a lot of people submitted this. I brought this, I found this at home. Just put your phone in there, and then you're ready to go. It's interesting. If you haven't tried out VR stuff, then you get a chance to do it. Next to VR, we have augmented reality and mixed reality. Microsoft HoloLens, this idea being you're not just completely in a virtual world, but things are being added into your real world. We see this on phones too. Apple seems really they want to do this, and it's horrible. No, their technology is really good, don't get me wrong, but I don't know why they keep putting it in their demos. Because, Google Glass is a bad example of how this happened. So another thing, mixed reality. Environments where, for example, you have motion capture, so you know where people are, and you project onto the environment, so they don't need to wear anything. You'll see a lot of this in places like Disney, theme parks, museums, interactive things that are augmenting the environment based on what people are doing. Wearables, we know quite a bit about wearables. Some of the interesting stuff, brain-computer interfaces, we'll try to talk about that a little bit later. And then I'll briefly play this tangibles video for you. Tangible computing is a whole area. I don't know why there's an HTML5 logo up there, but whatever. So the idea being that you have objects that you're tracking and sensing. I don't know. But you'll see this done with like RFID and stuff a lot. So it can make objects usable with an interactive system. You can do things like turn them and use tangible physical things to play in the environment. Nintendo's done a lot of this with kind of these cardboard kits to build little things that you can do to interact with your gaming system. So I'll go ahead and kind of wrap up there, but we also need to think about Internet of Things and consumer hardware. A lot of that is robotic stuff. I did bring us a Nest thermostat that I found, so that's pretty cool. Although it won't let me use it for some reason without being attached to an actual air conditioner. So maybe, I don't know.
Maybe a few decades ago.
Yes. So I'll go ahead and we'll stop there, and I will see you guys next week for FedEx presentations. Please submit your presentations at 11 a.m. the day before the day we start.